What's going on? Alfian here. So far in this channel, I've only uploaded SwiftUI based tutorial videos. But with this video, I'm going to start a new UIKit series with the focus on CollectionView, as I believe the skill set to implement CollectionView is an essential skill to have for any iOS developer out there. I hope with this tutorial series, it will help all of you starting from beginner to intermediate iOS developers who want to implement CollectionView into the app that you build. There are many amazing apps out there that have been using CollectionView under the hood to render the UI. For example, Apple's App Store, which uses the new compositional layout to render different grid layout for each different section. Second, Pinterest, which implements custom CollectionView layout subclass to render a staggered grid dash list. In this video, we start to learn the CollectionView by implementing the CollectionViewFlowLayout and the CollectionViewDataSource from scratch. Both of them are supported in all iOS versions. I know that on iOS 13, Apple had introduced the new Diffable Data Source and Compositional Layout API. I will cover those later in the future videos, as they are so simple to use. Sadly, they are not supported for iOS below 13. Along the way, we will learn and implement several new topics. Setting and configuring CollectionViewFlowLayout to show grid-based vertical layout with multiple sections. Using UICollectionViewDataSource as the source of data to render in CollectionView. Building Self-Sizing CollectionView Cell and Supplementary View with auto layout programmatically. With Self-Sizing Cell, the app will support dynamic font type for better accessibility. Using CollectionView performBatchUpdates to insert and remove sections and indexPaths in single transaction using Swift 5.1 Collection Diffing API. Finally, with SwiftUI Live Preview, we can preview UIKit-based View and ViewController for rapid prototyping in Xcode. Before we start to dive into Xcode, let me give you a short summary about the CollectionView and the flow layout. UICollectionView interface is quite similar with the UI table view, as it provides the data source to the queue reusable cells with data. Also, delegate to handle interaction of each cells. Unlike UI table view that layouts each cell using a fixed width, UI Collection View provides flexibility for developers to provide their own custom layout by subclassing UI Collection View layout if they want to. Apple itself provides a concrete implementation, which is the UI Collection View Flow Layout. The flow layout displays items using a grid-based system. It also provides two scrolling directions, vertical or horizontal. In the vertical scroll direction, the width of each item is constrained within the width of collection view bounds. For each row, the layout will try to fill as many items as possible before moving down to the next line. While on the horizontal scroll direction, the height of each item is constrained within the height of the collection view bounds. For each column, the layout will try to fill as many items as possible before moving right to the next column. The horizontal scroll direction is pretty good if you want to build a carousel-based layout. Okay, that's it for the summary of CollectionView and Flow Layout. Let's dive into Xcode and start coding. Okay, to follow along, please download the starter project from the GitHub repository link at the description below. Let me open the starter project in Xcode. The starter project contains the model and helper files. First, we have the character model. It has three properties: name, image name, and category. I've also provided 4 JSON files to help us stubbing the character from various universes, from Marvel, Star Wars, Final Fantasy, and DC. The JSON itself is pretty straightforward: an array of objects containing the key of name, image name, and category. If you see, it is a one-to-one mapping with the character model. I've also provided all the images inside the XCAssets folder. Using the image name property in the character, we can retrieve the image from the assets. The universe itself is represented in sign and enum. It has 4 cases: FF7R, Marvel, DC, and Star Wars. It has a compute property named stubs for stubbing the characters in an array. For each case, The associated JSON stub file is loaded from the bundle and decoded into the character model using helper extension. You can see the helper extension inside the stubs.swift file. Next, we have the section stubs computed property. It provides 2D array for multiple sections represented by array of section characters struct. Let's see the section character struct implementation. It has a category, string, and a characters array. For each case, after the JSON is decoded into the model, the characters will be mapped to the section they belong to using the category property. Finally, we have the title computed property. It will return the associated title for each of the cases. As we are gonna be using a segmented control to switch between universe, I've created an extension for the UX segmented control. It will help us to map the associated universe based on the selected segment index property. For the project structure, I'm not using a storyboard for this project. The entry point is located inside the scene delegate.swift. Here, I just cast the UI scene to UI window scene, and then I initialize a UI window passing the window scene. Then for the root view controller, I initialize a UI navigation controller passing a blank UI view controller for now. Then I set the window root view controller with the navigation controller and make it as key and visible. That's it for the starter project. We don't need to worry about the model and the stubs. So we can focus 100% to build the collection view. Okay, so our first task is to create the character cell. The cell has a rounded image to display the character image and a name label below it. Inside the views folder, create a new Cocoa Touch class. Make it as a subclass of UICollectionView Cell and give it a name of CharacterCell. Make sure to uncheck also create as XIB file, as we will create the layout programmatically for this cell. Click finish. To see the results of the cell that we will build, we are going to use SwiftUI Live Preview. First, we need to import SwiftUI at the top. Then, to show a UIKit base view in SwiftUI, we can use UIView representable. This protocol will act as a proxy to create an update UIView base class. Below the character cell, declare a struct named CharacterCellViewRepresentable. Make it conform to UIViewRepresentable. There are two required methods that we need to implement. First is make UIView context. Here we need to replace this UIView with CharacterCell. And inside the make UIView, we can just initialize the CharacterCell. We'll just set the content view background color as blue, so we can preview it later. Finally, return the cell. And the second required method is update UIView. Here, we don't need to implement anything. Okay, that's it for the character cell view representable. Next, to enable the preview, below the character cell view representable struct, declare a new struct named CharacterCell underscore previews. Make it conforms to preview provider. There's one required method that we need to implement, which is previews. We need to return SwiftUI view here. In this case, we can just return the character cell view representable. And let's set a frame here. Give it a frame of 150, 120 as the width, and 150 as the height. Okay, so to enable the preview, let's try to build first. Make sure there's no error. And then click on here. Click on this canvas. And then click on this prism. Nice. The live preview is rendered perfectly. Now we can build and implement the cell. As we're gonna build the UI with auto layout programmatically, we need to override the init frame initializer. Here we just need to call super init frame, passing the frame. We need to override the required init coder here. As we are not going to initialize this using XIB or storyboard, we can just declare a fatal error passing a string of XIB storyboard is not supported. This will crash the app if we try to add it inside a storyboard or XIB. Next, we need to declare a method named setupLayout. Let's set it as private func setupLayout. And then we need to invoke it after the call to server in the init frame. Okay, before we implement the layout, let's declare the three views. First, we have the image view. Let's assign it with UI image view here. Second, we have the text label. Can initialize it using the UI label. And we have our vertical stack view. Give it a name of vStack and initialize it with UI stack view. Okay, now we have all the views. Let's move on to the setup layout. First, in the setup layout, let's set the image view content mode as scale aspect fit. This will scale the content to fit the size of the view, maintaining the image aspect ratio. Next, let's configure the text label to support dynamic type so the user can customize the text size on the screen. From the settings, set the text label's font using UI font preferred font for text style. Here, we can just pass caption to as the text style. We also need to set the text label adjust font for content size category as true. Finally, we need to set the text label text alignment as center. Now, let's configure the stack view. First, set the axis as vertical. Then, set the alignment as center. And finally, set the spacing as 8. We also need to set the vStack translates auto-resizing mask into constraints as false. With this, the view's auto-resizing mask won't be translated to auto-layout constraints. This is required as we are gonna set the constraints manually. Finally, we need to add the vStack to the content view of the cell. And also, we need to add the image view and text label as the arranged subviews of the vStack. Make sure to add image view first. We have configured the image view, text label, and the vStack. Next, we need to set up the auto layout constraints. As the image view and text label were added as the stack views arranged subviews, we only need to add the constraints to stack view in relation to the cell's content view. We're going to use layout anchor to constrain the vStack to the edge anchors of the content view cell. Let's begin with the leading anchor property. We can use vStack.leadingAnchor constraint equal to. Here we just need to constrain it with the content view leading anchor. Set the constant as 8. Let's do the same for the bottom, trailing, and top anchor. For the bottom and trailing, we need to set the constant as minus. With this, the vStack is now constrained to all the edge anchors of the cell's content view. Also, as our image view uses square aspect ratio, let's add the constraint for the image view with anchor equal to the image view head anchor. We can use image view height anchor constraint equal to image view with anchor. To activate this, we can set the isActivate property for each constraint, like this. There's also another way to do it, which is to use the NSLayout constraint activate constraint. Here, it accepts the array of NSLayout constraint. We can just copy this, all of the constraints, cut it, and pass it here. We need to add comma. Let's clean these white spaces here. Using this NSLayout constraint activate, we can activate all the constraints together at the same time. Next, we need to create a method to inject the character, so we can set the text label with the character's name and load the image from the bundle using the character's image name property. Declare a method called setup that accepts a single parameter character. Here, the type of character. Here we can just set the text label, the text, using the character name. And for the image view, the image, by initializing UI image with name, passing the character image name. Let's see the result using the SwiftUI Live Preview. Navigate to the CharacterCell view representable. Here we need to declare a constant named character, the type of character. And then inside the Mac UI view, we need to invoke cell.setup, passing the character. And let's remove this content view background color. And inside the previews, we need to pass the stub character here. Let's use the universe enum using the ff7 arc case and retrieve the stubs array. And let's retrieve the first indexed, the first character, which is called strife. Okay, let's try to build and run and click on resume here. Okay, the character cell is perfectly rendered, but the image is not rounded. Let's implement the rounded image. Here we can just declare a subclass of UI image view named rounded image view. And we need to override the layout subviews here. Make sure to call super. Set the width to bound as true. And finally, we need to set the layer, the corner radius, using the bounds dot width divided by. Okay, so to use this, we need to update it inside the character cell here. Here we just need to initialize this with rounded image view. Okay, let's try to build and run the live preview again. Okay, now the image is perfectly rounded. Nice. Before we move on to implement the header view, I want to show you how we can render this character cell inside a SwiftUI LazyVGrid. Navigate to the previews here and declare a group. Let's move this character cell view representable inside the group. And then here we need to declare a scroll view. Inside we have a, let's scroll a bit here. Inside we just declare the LazyVGrid. We need to pass the number of columns for each line. In this case, I want to render 3 items per line. So I can just use a flexible here. Let me copy this two times. And then for the content, we can declare for each. We need to pass the array of characters, which we can retrieve from the universe. We use ff7r again, stubs. The character struct already conforms to the identifiable, so this will work. Here, let me copy this, and then I'm going to paste it here. For the character, we are going to pass $0. Nice. You can see that SwiftUI can also render a UIKit dash view. That's it for the implementation of the character cell. Next, let's move on to implement the header view. The next task we are going to implement is to build the header view for the section's title. Inside the views folder, create a new CocoTouch class. Set it as a subclass of UICollectionViewCell and give it a name of header view. Make sure to uncheck the also create XIB file. Let's also implement the SwiftUI Live Preview. Let's import SwiftUI here and create a view representable. Declare a struct name header view representable. Make it conform to UIView representable. And for the Mac UI view, just replace the return with header view. Inside the Mac UI view, let's declare the header view and initialize it. And for previewing, let's set the header view background color as red for now and return the header view. And for the other required method, update UIView here, let's just set it with empty body. Okay. Next, we need to create the preview struct header view underscore previews. Make it implement to the preview provider. implement the required static previews. Here we can just declare the header view representable. Let's try to build this, make sure there's no error, and let's activate the canvas. Okay, the header view is now rendered in the live preview. Let's implement the header view. Declare a private constant name text label and initialize it with UI label. Just like the character cell, we will build this using auto layout programmatically. So we need to override the init frame initializer, invoking the super init, passing the frame, and also for the required decoder, let's also declare a fatal error here, passing the message XIB storyboard is not supported. Okay, and let's declare a private method setup layout and invoke this inside the init frame. In the setup layout method, set the text labels font using the UI font preferred font for text style. Let's pass headline as the text style. Also make sure to set the adjust font for content size category as true to make the dynamic type works. Also set the text label translates authorizing mask into constraints as false. Finally, we need to add the text label as a subview of the header view. We are going to use layout anchor to constrain the label to the edge anchors of the cell. Let's assign all the leading, trailing, top, and bottom anchor. For the constant, we can pass 16. Let's do the same for all the other anchors. Make sure to set minus for the trailing and bottom anchor for the constant. Now we need to activate these constraints. Let's use the NS layout constraint activate, passing the constraints into the array so we can activate all the constraints at the same time together. Okay, need to add some commas. That's it for the constraints. To inject the text string, we need to declare a method. Let's declare a method here called setup with text as the parameter, the type of string. Here we just need to set the text label, text property using the text. We also need to declare the text here inside the header view representable, and inside the make UI view, let's remove the assignment of background color and invoke header view setup passing the text. Here, let's just hardcode, pass a hardcoded string here. Let's give it a name of heroes. Let's try to build and run. Nice. The header view text is rendered properly in the live preview. Okay, so that's it for the first part of the tutorial. In the next part, we are going to implement CollectionView in a View controller, and we'll set up the CollectionViewFlowLayout as well as the UICollectionViewDataSource. We're going to implement Self-Sizing Cell for better accessibility that can adapt to the thread collection changes.